Okay, so what I'm doing right now is trying to lay out various control points where the instrument is going to set. Because of the obstructions in the room, the columns and the offsets, we can't see enough of the surface from every point. So when the scanner's set up on, for instance, point 5, it's going to get a certain amount of data from that point, but it's obviously going to have a place it can't see. So when it moves to point 6, it's going to overlap the area of point 5 and add the additional area that it couldn't see from point 5 on point 6. So that it'll overlap and it'll stitch together, so that when all the scans are complete, we have the best perspective of all of the features here in the room. Okay, so we've established a horizontal control point on the floor. We've got the MS-50 set up over that point with the laser beam set on top of the point. We've already made some minor adjustments. Now we're going to make our fine adjustments to get the instrument level with the bullseye bubble. This is critical on each point because the continuity of the data from point to point to point is very dependent upon this instrument being very stable and very level. So now that we've got the instrument set up, level, and over the control point, we turn on the collector. Okay, so the next step is to remotely communicate between the instrument and the collector and the prism. So the instrument will actually do a search for the prism. When it recognizes the prism, it'll lock onto it.
Lock to target.
No. Okay, so the instrument is searched, it's found the prism, and it's locked to the target. So you can see that the instrument's going to follow the prism wherever I go. Okay, so now that we've got the total station set up and oriented to 2 control points, we can go into this Create Scan mode, which activates the scanning feature of this instrument. What we're going to do today is a full dome scan because we need to get the object straight above us on the ceiling. So we're going to select Full Dome Scan. And yes, we do want to include panoramic pictures. The reason for that is we want to get the RGB color features of the scan. When we import the point cloud into the computer, we want to be able to see what colors there are in the room to help us define objects. So right now the instrument's starting to take the panoramic pictures of the full dome scan. It's going to take 462 pick images and stitch them together so that they'll all be correct and tied to the other points after we move the instrument from point to point. All the pictures will be tied together in a stitched configuration. So now that we've completed the panoramic images, we're going into the scan mode. I've set the tolerance of the scan based on a distance of 110 feet, which is the farthest distance that is in my vision. And I've set the scan tolerance at 110 feet to measure a point every 9 inches by 9 inches. As you get closer to the instrument, that will become more and more dense, where the measurements I get on walls that are very near to me are probably going to be 1 inch by 1 inch or less. And so at this point, we're ready to start the scan. It's calculated the estimated time based on the tolerance that I've given it of 33 minutes.